This is AB Calculus. This is a test preparation problem for an exam we're going to be having shortly. And this is kind of a conceptual problem that it's sort of like figuring out what to do first. It will set you on the road to make quite an easy thing out of this. But what you have is a function defined by g of x equals x cubed plus ax squared plus bx plus c, where a, b, and c are constants. If there is a relative maximum where f of 1 equals 4 and there is a point of inflection where x equals 4 over 3, what are a, b, and c? Well, the first thing we notice is they ask us to find three constants or three unknowns, and they give us one equation. So in order to find these constants, we have to come up with other equations than this first one, because if we just try to, for instance, this first equation, which is f of 1 equals 4. Well, we can plug in 1 for x and 4 for g of x. Then we'd have three unknowns we'd have to solve for. So let's go ahead and work through this one. We're given that g of x is equal to x cubed plus ax squared plus bx plus c. I'm going to take the first derivative of this function, which we're going to call g prime of x. G prime of x is equal to 3x squared, using the power rule of differentiation, plus 2a x plus b. And so right now we have reduced our number of unknowns to 2 from 1. Now we just have a and b. And we know that there is a point of inflection, a relative maximum where f of 1 equals 4. So in this equation, we could plug in 0, because at x equals 1, we have a relative maximum, and then 1 for x, but still we'd have a and b to solve for. So we still can't find a solution for any of our constants. So we take a third differentiation, which is g double prime of x is equal to 6x plus 2a. So now we can actually solve this, because I'm going to put in substituting. What do we know about a point of inflection? Well, we know at a point of inflection, g double prime of x has to equal 0. So we say 0 is equal to 6 times our input value, which is 4 over 3, and then we have plus 2a. So now just multiplying through, 6 times 4 is 24, divided by 3 is 8. So 8 plus 2a is equal to 0. So 2a is equal to negative 8. And dividing by 2, a is equal to negative 4. So that's one of our unknowns that now we know. And so next we're going to go to the following equation, and we're going to plug back in to g of x, this time understanding the value of a. So we have g of x equals x cubed, and we have this, we know a is negative 4, so we'll say minus 4x squared plus bx plus c. And we're going to take a first derivative of this function with the improved level of information. So we get 3x squared minus 8x plus b. Well, now we have a function with one unknown. And so we know that there is a relative maximum where f of 1 equals 4. So if we plug in 0, because we know that g prime of x has to equal 0, that's g prime of x equals 3x squared minus 8x plus 8 plus b. So we put 0 equals, we're going to plug in 1, and so 3 times 1 squared minus 8 times 1 plus c. So what we have is 0 is equal to 3 minus 8 plus c, and so 0 is equal to negative 5 plus c. I said c, b. Get these letters mixed up. Okay, there we go. So 0 equals negative 5 plus b, so b is equal to positive 5. So that's our solution for b. And the last thing we're going to look at is to solve for c. And now writing out in red with the increased information, we have g of x is equal to x cubed, and we had from the earlier working minus 4x squared, and then we have plus, now b is 5, right? So 5x plus c. And let me go ahead and rewrite that 4x squared, not too legible. So minus 4x squared, 4x squared, okay? And we don't have to differentiate at all. We know that f of 1 equals 4, so we set g of x equal to 4. So 4 is equal to 1 cubed minus 4 times 1 squared plus 5 times 1 plus c. And we've substituted 1 for every place we've seen x. So 4 is equal to 1 minus 4 plus 5 plus c. And combining on the right side, we'll have 4 equals 1 minus 4, that's negative 3, plus 5 is, let's see, that's negative 3 plus 5 is 2. So 4 equals 2 plus c, and subtracting 2 from both sides, c is equal to 2. And so now we've solved for a, b, and c. And just to summarize, if we just wrote the equation totally solved for, we'd have g of x is equal to x cubed minus 4x squared plus 5x plus 2. And then if we differentiated this and went through the process, we would find our critical number here at x equals 1. We would find our point of inflection at x equals 4 over 3. So this is quite a nice little problem. Good luck in preparation for your test, and thanks for viewing.